I'd like to introduce my first speaker. Jennifer Fogarty is the NASA Human Research Program Chief Scientist. In that role, she works with the HRP elements on the development and oversight of the research portfolio, addressing the diverse human system risks that need to be characterized and mitigated to enable human exploration of space. This requires communication, collaboration with current flight programs, international partners, as well as developmental spaceflight programs that will be implementing risk reduction strategies, strategy-based HRP research, and risk mitigation strategies. In addition, Dr. Fogarty establishes and maintains relationships and collaborations with external institutions and other government agencies to assess fundamental mechanistic discoveries, as well as innovative prevention and treatment strategies. Dr. Fogarty, welcome.
Hi, thank you. I appreciate it. I have one correction to make, and it probably was my fault that I might have emailed a slightly older biography. I recently left NASA about 8 months ago. I am now in the private sector. And Rand, I couldn't agree more with the statements you've made. And internally at NASA, it was a struggle because for the reasons you exactly stated, with the limited data working on the human research side. So most appreciated for that introduction. And I really value what Space Tech Analytics is doing. I've been watching the types of analysis they put out, and I was and still am a major advocate of that type of crowdsourcing of data. And it would be really great if we could continue to make the data that was collected available for deeper analysis. I think, you know, a lot of for the hypothesis testing was great, but many more variables were collected, and many different types of analysis could be done on that data and give us new and different insights. So I'm looking forward to see what Space Tech Analytics is going to continue to be able to do. And of course, with commercial space, to your point, it's really opening up the sector of who will fly. But it also represents some other challenges, which are people are paying for these flights. They want to be able to enjoy them. They want it to be aesthetically pleasing. So new requirements, and not that that's out of line actually with kind of human-centered design, but engaging in human research sometimes has, you know, some challenges. Not every experiment is painless, and there's just a lot of logistics around it, and microgravity makes that incredibly challenging at times. So I am currently with a company. It's a small woman-owned human-centered design firm, Sophic Synergistics. I am the director of the Applied Health and Performance Division that I'm growing, and just building a network and working across a lot of different sectors to look at application of tools in other ways than they were originally intended. And I'm also very passionate about spin back to Earth. So development for spaceflight, given the enormous constraints and challenges that are present, and bringing them back to Earth for application in many different ways. So that is my current position, just to clarify. So when we think about spaceflight and maintaining health, being healthy in space, there's a lot of pieces to that, and one of them is your baseline health. And as you correctly mentioned, Brand, there is a selection process to get into the astronaut corps. There is a healthy worker effect. These are intelligent people, highly motivated, so they invest in their health, and do represent a different population, more than one standard deviation in many ways. But in other ways, they are human. They are vulnerable. They have genetic predispositions, which we may understand and mostly don't understand. But when you put them in an extreme environment, a lot of things can be revealed. It's also, you know, for the 16 years I spent at NASA, was a privilege to start to be a part of mapping the adaptation to spaceflight, microgravity, and also the ability of the human body not only to adapt, but to react to rapidly changing environments, which is one of the most challenging parts of spaceflight. When you get into an environment and you allow the body to adapt, you reach an equilibrium and people are very highly functioning. But when you change that environment incredibly rapidly, such as at launch and at landing, and eventually we're going to be landing it back in a less than 1 gravity field, those can be very challenging, very disruptive, and drive things that you really have to anticipate, because this is where the vehicle is going to have to make up for the limitations on how fast a human can adapt. So there's a spectrum of pictures we'll probably be going through, and I'll be mentioning a lot of what's going on, but there's a breadth and depth of activities, a breadth and depth of context that you should think about. So we're going to start with Earth, and we're going to just spend a moment. I want everyone to think about the challenges we have at maintaining health on Earth, with a lot of resources and a lot of opportunities, but not equally available to everybody. So we know a lot about the limitations in countries and continents where healthcare is challenges. We also understand that culturally, medicine is not practiced the same way all over the globe, and yet can be very successful. So you have to look at all potential resources that might be brought to bear, and at least give some thought to how you might do it in the extremeness of something like space exploration. I also use this image when I do talk about space flight to remind folks that what we take for granted, and that space flight removes the ability to take things for granted. The vehicles become essentially your exoplanet. The human is exquisitely vulnerable to the vacuum of space. It does not have a breathable atmosphere. Neither do the planets we're talking about that we will be going to in the near term, the Moon and Mars, planetary bodies at least. So you really have to pre-think and pre-measure to be able to anticipate. And you do have to use tools to give you those insights and be able to extrapolate to where is this taking a human body? How is the body going to try to achieve balance, and what does balance mean? Because I think there's a fallacy out there that you should not try to keep people Earth normal. That is actually, I think, an unacceptable goal. You should understand how the body adapts to various environments, which happens on Earth as well when people put themselves in extreme environments. And the key is to understand if that adaptation is taking you in a positive manner towards success in terms of health and performance, or is it leading you down a detrimental trail? And those can be challenging to measure right now, and get that foresight to know where it's taking you. And we actually have examples of both from the space flight that we have done. And of course, in the next 10 or 15 years, the ultimate objective is to be able to get to Mars, an extremely austere environment, an inhospitable environment. So going back to that vehicle, the transit alone, without a change in propulsion, 9 months under the best of conditions, is going to really impose extreme stressors on the human body, the isolation, the confinement, the galactic cosmic rays, the biological damage that could ensue from that, potential for solar particle events, the ability to provide enough water, enough food, the type of nutrition, and the psychological well-being. So a lot to unpack here, which I'm not going to be able to accomplish in 20 minutes with much depth, but just to be sensitized to the fact of, again, you're going to have to think about allowing the body to adapt, even if you're a commercial astronaut and buying a ticket, or a government selected astronaut going on behalf of your nation. It's still the same human you're sending, right? It's the same robustness and the same vulnerability in concept. And how do you prepare for that? So a lot of questions are about why we even go. We can send the rovers very successfully from here. We can map those planets. We can even do some analysis. We're getting better at that. And we'll need that for humans, even if we go. Remote in situ analysis is the key. Bringing samples back is somewhat of a daunting and unrealistic task, especially when you're talking about the human on the surface and having to get relatively quick information about the status of that human. So I think we dare for many reasons. And I do think it's an appropriate goal and passion of the human race to explore and understand things. And it's also a galvanizing need, right? We get to the point of where we have unsolved problems here on Earth. We continue to create our own problems that we just can't get out of our own way. But when you go to space flight, suddenly the true needs and desirements of how you accomplish that become very crystallized because of the rarity of resources allowed. So solving problems gets very pointed, and somehow it has driven such a multidisciplinary, multinational approach that I think it's one of the keys to be able to spin back things. So it is the ultimate in living off the grid, right? Again, about building this exoplanet, recycling, the concept of what waste is and reusability. It's a fascinating approach, a microcosm, if you will, to probably solving a lot of our problems back on here that we just can't seem to galvanize ourselves to do. So when you think about what's going to happen and the challenges of exploration, I mentioned radiation, both cases, the omnipresent high energy particles known as galactic cosmic rays that can damage DNA and cause a lot of inflammation, and they're just chronically present. They actually, when they pass through an aluminum shell of a vehicle, actually undergo a transformation, and are piece parted out and reveal an even more dangerous version called a neutron that is even biologically more problematic. So this tension between having to have a shield, and of course, aluminum is the choice, and I believe it's 23 centimeters squared is the density that is most appropriate for optimal radiation shielding, but it does cause a different problem. Those neutrons are problematic, to say the least, when they're inside that vehicle bouncing around. And we haven't figured out a way to engineer those out. So we're going to have to work on the biology. How do we protect the people? How do we prevent, a biological consequence? And how do we help the body repair itself? And it's tied into nutrition, and it's tied on into psychological well-being. And then, of course, there's forecasting for solar particle events. What behavior is going on with the sun? Where is that projection going, and how damaging could it be? And how do we protect the crew from SPEs, which the magnitude and the catastrophic consequences of a severe solar particle events to the crew on a transit to the moon or to Mars is mission ending and life altering, if not life ending. So those are always constantly in the mix in terms of probabilities and consequence, and how much do you mitigate and prevent, and what tools are in play versus where does research need to come in and develop some solutions that we don't have. Altered gravity fields. You're going to go from 1G very quickly into microgravity. The body is going to transition and try to adapt. There's a diuresis. There's a huge blood volume shift. Sensors in your body are being overwhelmed and think a different problem is happening. Some tissues, become swollen and edematous, and they start to actually change over time because of the fluid pressures in them. And we see that in the eye, in the brain. And so right now we monitor those things. 6-month missions on ISS allow us to characterize them. And it's been very challenging to get data, most of which is collected pre-post, the highest quality data, but it's very challenging to get the data to do legitimate extrapolation. So I think, in the realm of space tech analytics, like if we could open the kimono and do crowdsourcing on the type of data that's been collected, I think amazing insights could come out of it. But because of the construct under which it's collected, privacy and the rules around the ethics of using people's data is very challenging to that. And not so much that the crew does volunteer, don't get me wrong, they are test subjects and they're very altruistic, but most of the time the data will reveal who they are, by name. Ultimately it will be very easy to figure out. And that kind of privacy intrusion has been very problematic to solve. So the more people we get to go, the more people who volunteer in any capacity who go to spaceflight, it starts to open up that space of being able to protect people's privacy and do data analysis and keep their identity protected while revealing the things we need to know about how humans adapt and change. Hostile closed environments is really talking about the environmental control and life support system. How do you clear out the CO2? How do you recover the condensate and the humidity recycle as water? How do you make sure that water is potable and not contaminated? If people are on medications and you're recycling urine, how do you make sure that you're able to eliminate metabolic byproducts of medication that one crew member is taking, so the other ones aren't drinking a secondary or tertiary byproduct. So there's a lot of engineering that's good and even great, but it's still not what it needs to be to go to Mars. The other part of this is that for those systems that have been developed, is there a way to get them back on Earth and do better water conservation and make sure we can deliver potable water to people in areas that don't get it? And, you know, Engineers Without Borders does amazing work, and could they benefit for things that have to be so remotely deployed and light and lean and robust? You know, we do repair stuff on orbit now. I think part of the job of any astronaut going anywhere is to be a housekeeper. But the deal is that it has to be repairable, and it has to be repairable with parts you can either bring or hopefully make via 3D printing, at least the concept of. Isolation confinement is speaking to the behavioral health and performance effects of spaceflight, of any exploration really, where you have a few number of people who are confined to a very small space for long periods of time, and they're not getting a lot of stimulation, right? You have your 3 walls, if you can measure walls in a circular capsule. You don't have a lot to look at. So where does augmented reality and artificial reality come in? Because there is a lot of data, particularly from the Antarctic work that talks about, you know, deprivation, you know, leads to changes in the brain. So this is where psychology, physiology, biochemistry all triangulate together, and people's behavior and feelings, emotions, and temperaments may change, and not for the better if you're not managing the situation and giving people the tools, you know, to manage it as it's happening. And distance from Earth always comes up, because part of a mitigation strategy is, if we really get it wrong, or if the bad day really happens, how do we get them back? If you're close enough, like the International Space Station, within a day, the ride down is, you know, once it's determined that you can return and you deorbit, it's kind of a 3-hour deal, but it's really challenging. And distance from Earth, as it gets further, you lose that ability to come back. It's no longer a mitigation strategy. So what types of solutions when you do work do we need? Definitely robust. It's got to be reliable. These are not things, if they easily break, you can't get parts, or it's not something you can work on. That's just not a tolerable component to something that's already pretty austere. Autonomous. And there's a little bit different, I should change that terminology and put both on there. Automated, meaning that the thing runs itself, versus autonomous, meaning that the crew can run it without ground support. Light and lean, meaning it's not going to put a lot of mass, or it's multi-purpose. When you want to understand someone, do blood analysis, maybe the same device could do blood analysis that could also test the potability of the water and the quality of the air. And lean is really about without, you know, fringe. What doesn't it need? Comprehensive probably speaks back to that idea of multi-purpose. If you need to do voice analysis to understand someone's mood and give them back kind of feedback on their psychological state, that should be done through the guidance, navigation, and control display system. You know, right now we have separate computers on ISS that do the medical hardware versus the ones that run the station and talk to the ground control. And we are not going to be able to tolerate duplication of hardware for different purposes. The data and predictive analytics driven, that everything should be collected and be surveilled for what's changing. I always think of things as a dashboard, and where are those dials going? And do we know quantitatively when dials are changing in relation to each other, when something's going to hit a red line, or which ones are going to be a tipping point for a bad event or a good event? You know, you're on track. You know, some feedback to the crew is always a huge benefit. They have awareness. They are active participants in the work. When you do research with humans in spaceflight, it's field research. It's not laboratory quality control everything. And most stuff is out of your control, and you are trying to design something so that you can still learn from it. Agile and responsive to a changing environment. Mentioned, you're going from microgravity to partial gravity. You're gonna, when you do the shift, you're exposed to extreme G forces at times. Landings can be pretty rough. Injuries could happen there. You know, did the microgravity component in your deconditioning, make you more vulnerable to a hard landing and having some type of musculoskeletal injury that then, if you're landing on Mars in particular, are, less capable of doing an extravehicular activity. And do we have the hardware for you to recover and treat you medically? So those scenarios play out often. You have to do a lot of concept of operations to kind of tease out, well, what are we trying to accomplish? How do we think we're going to get there? What's the vision? And then decompose it into the areas of do we have solutions to those challenges? If we don't have solutions, we have a gap. What kind of research and development do you do? And how do you start plugging those holes and get validity? So when I used to work in my prior profession, it was really about developing a medical and performance system. And I would talk about, like, in your mind, if you're in such an austere location, what would it take to deliver medical care in this scene? The red planet. You either have to bring it with you or be able to make it there out of in situ resources. And maybe you're lucky enough to have the foresight to have pre-positioned something, but there's a lot of components that you need to know. And at some point you're dealing at a pretty high level with the human and physiology and functionality, but it would be really great to know the underlying biology, to catch things early, to do real preventive medicine. And the slight differentiator being, like, on the way, can you continually promote health, not just prevent disease or detriment, because you want to build up a reserve, because there will be challenges. There will be sleep deprivation. There may be incomplete nutritional requirements. Those things are very likely to occur. So because the body demands things at different times, right? It's a very spontaneous organism that's trying to accomplish a job. And so we will not have every strategy to build that network. So could we, again, promote reserve in areas that we know are high value in terms of the human being successful? And part of that is the mental health component. So when you think about the ISS, it really is an amazing research opportunity. And I know one of your next speakers is coming on and going to be talking about the capabilities up there with the International Lab. I mean, you're talking, you can study the human, you can study an organ, a tissue, a cell at the molecular level and more, with DNA sequencing and RNA sequencing, understanding the microbiome of the human and the microbiome of the built environment, the connection between the two. There's an amazing amount of resources, and internationally we do work together. So up on the right, you see one of the crew members in what's called Chibis, which is a lower body negative pressure device. It's essentially a vacuum a device that pulls a vacuum to replicate 1G with respect to the cardiovascular system, not so much to the musculoskeletal system, a little bit of pull on the bones and ligaments and joints to give those sensors kind of some feedback, but it's really about sequestering that venous blood supply for a while and challenge the cardiac function, because it's actually been the large majority of the volume has been residing in the upper half of the body, and the heart perceives that as volume overload, which is why you get somewhat of a diuresis. But how it just continue, it's a closed loop, so pressure's there, heartbeat, blood pressure are all regulated pretty well. But those pressures, the volume pressure in the upper body is having some effects that probably are not consistent with being successful at a 3 and 4 year mission. The space-associated neuro-ocular syndrome is not trivial. And I think we've spent about 5-6 years really characterizing it in depth, and it needs a lot more attention. And we need to really elucidate what's going on in the brain to really understand this thing and figure out how to prevent it. And there is a lot of work going on, but it's still in kind of this nascent phase. Ultrasound has been our go-to diagnostic tool. Imaging wise, it really has proven itself to be such a robust medical diagnostic capability. And it's also, that actually has spun back a lot to earth for a much more ubiquitous use across many areas of medicine, not just OBGYN or it's now musculoskeletal. It's actually, NASA drove a need for diagnosis of kidney stones, and it's actually moved into therapy, being able to move kidney stones, bust kidney stones up. So some interesting work there with not only diagnostic, but treatment capability. Bottom right is a fundoscope going back to the eye. And the point is, we often need tools where the crew members can manage themselves, where you're not losing another crew member to be an operator. So self-administered testing. And then of course you see Scott Kelly when he injected himself with the flu vaccine when he was up there for his 1-year mission. And he had, you know, while we talk about changes in the immune system and the word decrement or detriment is often used, the immune system is definitely changing. You know, the measurements that are made are real, but it is still very robust in terms of when provoked, it has a response. So there's two different aspects, at least two different aspects to your immune system. And when challenged by an external force, the immune system is a robust responder. The crew is not acquiring, you know, particularly post-landing is one of our biggest examples when they're being interacted by so many humans on landing day, they are not falling ill, right? So the immune system, again, can come in and mount a response, but they are having some interesting autoimmune effects, and that requires a lot more study. So why is the human becoming hypersensitive? That comes up with the skin rashes, and there may be more than one reason for that, particularly with microbiome. But that's one area, particularly when you send a much larger variety of population, you're going to see some interesting things happen. I won't say bad necessarily, but it's going to be a dynamic one, and it's going to be hard to have a medical system that's prepared for all the possibilities. So that will enlighten people as they go that space flight is hard and challenging. So the more near-term missions that are very short, like the 4-day Inspiration 4 mission, you know, even Blue Origins missions, those, you know, you gotta crawl before you can walk, before you can run. So I think it's a growing opportunity.
Doctor, but yeah, we're kind of running over. His problem with doing Zoom is you can't give visual cues to people.
Yeah, no, I appreciate it. And I don't have a clock up either. I was hoping mine would stay up. So there's a lot going on in International Space Station, and they are offering different opportunities to be more exploration-like in some of their operations. So this is an open area for people who are going to go there. And I won't go into detail here to just cut out time, but you know, analogs on the ground, I think a lot of the next couple speakers are going to talk about them, and some have even participated in them, are really key at laboratory quality simulation of exploration stressors. So they are all valuable in different ways, and they are pieces of a much larger puzzle that need to come together. And I think a lot of the data analysis is key to that. And then of course, genomics, precision, personalized, that's really going to be key. Epidemiology level gets you kind of to a bullseye. This gets you to the center of the bullseye. What matters to that person? Because ultimately, you know, statistics can tell you, probabilities can tell you what might happen to you. Get it? Like Framingham risk score. What's your risk of a heart attack in the next 10 years or stroke? But does that matter to any one person? No. You got to be better than that and smarter than that. And we actually are. We need to learn how to apply it. And we also need to know how to grow the capability. So when you hear about precision medicine now, pieces of it are out there, and it's growing. And every day there's another 100 articles added to the evidence base, quality to be determined. But we've got to keep our eye on the prize, which from efficiency, effectiveness standpoint, precision medicine is where we need to go. And the twin study and the 1-year mission was really designed to start NASA on that road. So to end, a comprehensive human-centered approach is going to acknowledge and prepare for all the complex needs that the human's going to have in these challenging and dynamic environments. And only that type of approach is going to result in an exploration journey where humans are going to be capable of surviving, and I think thriving, to do the job we ask them to do. And that is my get off the stage slide. So I really appreciate the opportunity. I think you guys have an interesting group, and I'm looking forward to seeing what Space Tech Analytics puts out there in the next couple of years for sure.
Thank you very much, Doctor.